Hi dear students, once again welcome back to our channel. We are continuing exercise 9.1. Question number 5. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming there is no slack in the string. So read the question carefully, children. Okay, because lengthy question and figure also not given. That means you should read the question carefully, then only you can draw the figure correctly. Okay, without the figure we can't solve this problem. Okay, this picture is clear, children, because many situations we are familiar with this situation that is explained in the question. That is a kite which is flying 60 meters above the ground. Okay, and the string attached to the kite is tied to a point on the ground. Okay, so at present, see, this is the ground. This is the ground. See, here is the 60 meter above the ground. Okay, and at this point, the kite is now at that point. That is 60 meter above this ground. Okay, this is the ground. Okay, and this string attached to the kite. Okay, see children, now the kite is at this point which is 60 meters above the ground, and the string attached to the kite is tied to a point on the ground, and there is no slack in the string. Okay, and this is the way that the kite is attached to the ground. At a degree is the inclination between the string and the ground, that is given as 60 degree. Okay, that means here at this point the angle of elevation, that idea. Okay, that means here at this point the kite is here. Okay, and find the length of the string. This is the string, this is the length that we need to find out. Okay, this is the ground level, that is 60 meters above the ground level. Now the kite is there. Okay, at this point that kite is attached to the ground with an inclination of 60 degree. Okay, and we have to find out the length of the string, and this is the required length. And obviously this height, that is perpendicular to the ground. Okay, assuming that this is perpendicular, the height is always the perpendicular distance. Okay, and we can consider a right triangle ABC. Okay, and here this AC is with respect to this 90 degree, this is the hypotenuse, and we need this one. That means we have to select a ratio by using trigonometrical ratio and the values, that is a specific angle, that is 60 degrees the angle of inclination, that is angle of elevation. Okay, and here this opposite side with respect to this reference angle, acute angle, this is the opposite side. And this is the hypotenuse side opposite to 90 degree. So opposite side by hypotenuse, that is the ratio to be taken. Okay, that comes in sine as well as cosec. That is opposite side by hypotenuse is sine theta, or you can take hypotenuse by opposite, that doesn't matter. Idea is clear how this ratio can be selected. Okay, so we can start the solution. That is, consider right triangle ABC. So which is a ratio? That is sine 60 degree. This is acute angle's measurement is given as 60 degree. So sine of 60 degree equal to its opposite side AB. Okay, that is a known value. We can't take this one. If you are taking this adjacent with the hypotenuse, both will be numerator and denominator will be unknowns. Okay, so that you have to select this ratio. Okay, that is AB by AC. AC is the required length of the string. Now we can substitute for sine 60. What is the value of sine 60? 0, 1 by 2, 1 by root 2, root 3 by 10, 1. That is the first row, and 60 for sine 60, that is root 3 by 2. Root 3 by 2 equal to AB, that is height of the that is string, that not string, height of the kite above the ground, that is 60 meters. So 60 divided by AC. The only unknown is AC. Then you can cross multiply, you can take AC, okay, to the numerator. So root 3 AC equal to cross multiplication 2 into 120, 60, that is 120, that is 120, then AC equal to 120 divided by root 3. Since the denominator is an irrational number, we have to rationalize, okay, by multiplying with root 3 and dividing with root 3. Now root 3 and root 3 become 3 and you will have 120 root 3 divided by 3. This 3, root 3 into root 3 is 3. And 3 in 120 get cancelled. Okay, so 3 in 12, 4 times and 0, that is 40 root 3 meter. This is the length of the string which is attached, okay, at the top to the ground, and the kite is 60 meter above the ground level. Okay, so this is all about the fifth question. Now the sixth problem. A 1.5 meter tall boy standing some distance from 30 meter tall building. The angle of elevation from his eyes to the top of the building increases 30 degree to 60 degree as he walks towards the building. Find the distance walked towards the building. Okay, so as usual the figure is not given. So read the question 2-3 times and understand the meaning. Okay, should have an idea of how that picture will be. Okay, so that you can easily draw the figure and solve the question also. Okay, so here a boy is standing on the ground. This is the ground. He is standing here. And from his eyes, the angle of elevation towards a building and whose height is given as 30 meter. Okay, from his eyes means here the observer is standing on the ground. Okay, so the height of the boy is given as 1.5 meter. And from his eyes, okay, that angle of elevation, okay, so here this is the building and whose height is 30 meter is given. At the top of the building, the angle of elevation from his eyes means this is the line of sight. Okay, that is the line segment joining the eyes of the observer to the topmost place. Okay, at which that observer is viewing that object. Okay, and here this angle of elevation is given as 30 degree, increases 30 degree to 60 degree as he moves towards the building. Now the position of the boy is here, okay, and at present that angle of elevation from his eyes to the top of the building is 30 degree. Okay, that means this angle of elevation is 30 degree. As he moves towards the building, that angle of elevation get increased. Okay, then that is given as 60 degree. Okay, and we have to find out the distance he traveled, he moved, okay, from 30 degree to 60 degree. Here the very important point where we can mark this angle, okay, that means the line segment, that angle between the line of sight and the horizontal. Okay, here the ground level actually, but since that angle of elevation from his eyes, okay, and that horizontal level is always parallel to the ground. Okay, as we move straight, okay, our eyes, that eye level is always parallel to the ground, and that line is what we call horizontal level. Okay, so here comes, we have to draw a line which is parallel to the ground. This is the ground. So from this, the angle between the horizontal and the line of sight, that is angle of elevation that we know. Okay, and from this point 30 degree, as he moves towards the building, the angle of elevation definitely get changed. That is, it will increases as we move towards the perpendicular. That means here at this point it is 90 degree. This is also 90 degree. Okay, the building and the ground make a 90 degree angle. Okay, so as he moves from this point towards the building, the angle of elevation also gets changed, and that is given as 60 degrees. So suppose at this point, okay, after moving some distance, he reached at this point, and from that point angle of elevation is given as, at the same point he is watching the top of the building. Okay, so here at this moment, that angle of elevation is given as 60 degree. Okay, and what is asked? The distance from this point to this point. The distance he walked towards the building. This is the building. Okay, he is approaching to the building, and for that this is the distance. This is the distance moved by or walked by that observer. Okay, as a result of this increase in that angle of elevation, but is 30 to 60 degree. So this is the picture, children. Okay, so this is very, very important, and after that you can just name and consider the right triangle so that you can easily solve the question. Okay, and for that I am naming this A, B. We are not considering this ground level because we have drawn a horizontal level parallel to the ground. Okay, so no need to consider these positions. Okay, and this is A, B, and this point is C, and at present that initially that boy is standing at the point D. Okay, and we have to find out from the figure from this point to this point, that is the DC. DC is the distance walked by that observer towards the building as an increment of that angle of elevation from 30 degree to 60 degree. Okay, that picture is clear, children? Okay, and how to find out this DC? Okay, and for that what all things we have given? We have given only angle of elevations and the height of the building. Okay, here another point is the building is situating the ground. Okay, and here we have considering only from this position. Okay, we are considering the right triangle ABC and right triangle ABD. That means we should get, this is the side of the triangles ABC and ABD. So we should get this length. Okay, from this ground level, suppose this is E. Okay, we have to subtract this BE, and the boy is always standing parallel. Okay, parallel. So that means this length, that is the length height of the boy, should be subtracted from the total height of the building. Okay, that means the building is on the ground level. Okay, so this BE is equal to, from the figure, BE, this length, okay, is equal to the height of height of the boy, that is 1.5. That should be subtracted, then only you will be getting that actual length of the AB. Okay, that means we are considering only this portion. Okay, because there that right triangles are formed. Okay, so AB is equal to AE, the total height of the building, okay, minus BE. Okay, that means 30 minus 1.5, which is equal to 28.5. So we have AB is equal to 28.5 meter. Okay, now see children, you can consider two right triangles, triangle ABC and right triangle ABD. And next step is for the selection of ratio. Okay, that ratio should include this side, that is BC as well as BD. Okay, BC is the side of the right triangle ABC and BD is the side of right triangle ABD. And here that angle of elevation, so opposite side, its measurement we know, and this one, that is the adjacent side. With respect to this as the reference angle, this is the adjacent side. So opposite by adjacent is tan. Here also you have to consider tan of 30 degree. Here also tan of 60 degree. Why we are selecting tan is clear, children? Okay, because we need the answer in terms of this horizontal level which is parallel to the ground. Okay, that is actually this is the adjacent side of this angles, that is 60 degree acute angles and 30 degree. So when you are considering the ratio, that should be there, that side should be there. Okay, and for that we can consider tan of 60 degree and tan of 30 degree. Okay, so consider right triangle ABD, the big triangle ABD, because initially that angle of elevation at the starting point, that angle of elevation is 30 degrees. So that big right triangle ABD, as I told, we can take tan. Okay, tan 30 degree equal to its opposite side AB divided by BD. Okay, and we can substitute the value of tan 30 as 1 by root 3 equal to AB. We have 28.5 divided by BD. Children, from this figure, what is the distance travelled? DC, and DC is equal, the distance travelled, DC is equal to BD minus, if you subtract this BC from BD, you will get that required answer. Okay, that is BD minus BC. This is the distance, okay, that he walked towards the building as a change of angle of elevation from 30 degree to 60 degree. That is the required answer. Okay, and for that we in the answer, okay, we should have that this side should be there. Okay, so we have here BD. Now the next step is BC. We need BC. Okay, so for that we can do the cross multiplication. Okay, BD into 1, that is BD equal to 28.5 root 3 come to numerator, cross multiplication. Okay, so root 3. This is BD. Now in order to get BC, then only you can subtract. BC is the side of the right triangle ABC. Okay, so in right triangle, now we are considering right triangle ABC. Triangle ABC. Again tan, because adjacent side should come. Tan of 60 degree. Here the acute angle. In right triangle ABC, acute angle is, reference angle is 60 degree. So tan of 60 degree equal to AB by BC. Okay, and what is tan of 60 degree? Root 3 equal to AB is 28.5 divided by BC. Then you can cross multiply. We should get the answer with respect to BC. Okay, so BC will come to here and root 3 come to denominator. Okay, so 28.5 divided by root 3. So we have now BD as well as BC. What is the required distance? That is DC. So in order to substitute, okay, get the DC, okay, equal to BD is 28.5 root 3 minus BC is 28.5 divided by root 3. Since these two terms are separated by minus, you can take that common factor, that is 28.5 is common. So 28.5 by taking outside, that factor remaining in the bracket is root 3 minus 1 by root 3. Then cross multiply because minus sign is there. So root 3 into root 3 is 3. 3 minus 1, that is 2 divided by root 3. That step is clear, children. So this is equal to 28.5 into root 3 into root 3, cross multiply. So 3 minus 1, okay, divided by root 3. Okay, so here we have 28.5 into 2, 3 minus 1 divided by root 3. This step is okay, children? Okay, so in the next step, what is 28.5 into 2? Here comes DC. This is the required distance. So DC I am writing here. DC is equal to 28.5 into 2 is 57. So DC equal to 57 divided by root 3. Here also the denominator is an irrational number, so that we have to rationalize using root 3 under multiplication and division. Okay, so root 3 and root 3 become 3 and 57 root 3 divided by 3, and 3 in 5 one time, and in 27 19, so 19 root 3 meter. This is the distance walked, that he walked towards the building as this 30 degree changes to 60 degree.